Hi everyone, welcome to tutorial 33 of our introductory Python for image processing tutorial series. In today's tutorial, I'm going to talk about median filter. And again, in the last tutorial, we talked about Gaussian filter. So let's see how median filter can be better at cleaning up salt and pepper noise. And again, this is probably a common filter that you have used in the past as part of your routine image processing in ImageJ or other software. In fact, just to show you the effect of median right away, let's switch to Zen. And again, Zen Lite is a free software to download. If you don't have it, go ahead and Google search Zeiss Zen Lite, Lite, and typically it's the first link. Go ahead and download it, and it's a great piece of software for desktop based image processing, especially to handle like large files and everything. Okay, so again, this is not a Zen tutorial, so let's focus a little bit on the image processing aspect of it for now. So just to show you the effect of median filtering, let's go ahead and type median and select it and go ahead and apply it, and almost instantaneously, just like magic, almost the image is not even distorted much, yeah, as you can see. So this is our original image, and it's almost like magically all of these pixels are cleaned up. If you see, there is a lot of noise around here, and if you zoom in, not much. Okay, so in fact, it looks like it took care of almost all of these spikes here. So median can be a great filter for salt and pepper. Now, why? Let's actually get back to this tutorial so I can explain exactly what's going on in the background. So first of all, a quick reminder about what exactly is median. Right? I mean, we learned this in probably our elementary school, but oftentimes we forget things. If you look at house prices in your neighborhood, they're typically, they give you the median house price, right? There's a reason, because you have a normal range of house prices, and then you have these rich guys living up the hill where the houses are a bit expensive. If you just look at the mean value, the mean is almost $1 million here. But median is about $512,000, which obviously represents this data much better than the mean value. This is exactly what we are going to use for cleaning up our image that looks something like this, for example. And then you look at this small area, and then you have these spikes, and how do we take care of these spikes? Now, first of all, to further illustrate that, let's say this is our image, and there's a wild spike right there with a value of 255, right? This is our bright pixel. How do we take care of this? Now, first of all, median is, we just saw that you take a median of all of these numbers. So if you take 128 and all of these and arrange them and look at the median value is 140 in this grid. So you replace that with 140. So there you go. Your image is cleaned up. So this is the principle behind median filtering. So let's actually jump in and write a few lines of code for median in Python. So again, as usual, I have some lines pre-written. So I'm going to copy the first few lines first. Again, we'll have a look at it. So here, I'm importing OpenCV and scikit-image, possibly because I want to demonstrate how to use median in both packages. Again, it's up to you which one you want to use. The math is the same. So I'm importing two images. One I'm calling Gaussian noise, and the second one salt and pepper, exactly the same that I've used in the last couple of tutorials, where the Gaussian noise is where the image actually has this Gaussian noise spread around, and salt and pepper, as the name suggests, it's a salt and pepper noise. Now, first image, let's actually, instead of that, let's actually define our first image as Gaussian noise image, and let's see how median filters our Gaussian noise. Okay, it's not as good at cleaning up Gaussian noise as it is at cleaning up salt and pepper, by the way. And how do you apply the median in OpenCV? It's just one single line. My median image using CV2 is just cv2.median blur. That's it. All you got to do is, okay, what's your input image? Your input image is IMG, which is our Gaussian image right now. And then the kernel size is 3. That's what that 3 represents. And in scikit-image, it's very, very similar, except in scikit-image, to define your kernel, it actually uses something called disk. Okay, so the way you apply this is, again, only focus on this line first. Again, I'm using exactly the same terminology there, median using scikit-image. How do you apply it? Just median. okay, because we already imported it from filters. This is where we got from scikit-image.filters, we got our unsharp mask and also the Gaussian, right? So this is where all the cool filters actually reside in scikit-image. So let's import the median, and we are applying it on our image, just like any other filter. And instead of kernel size, I'm creating a disk size. In fact, I think it's important to explain because we use this disk a few times. From scikit-image.morphology, just import disk. Okay, now let's say my A equals to disk of size 3, of radius 3. Okay, now if I plot A, this is how the kernel looks like. Okay, so in a way, I'm generating a kernel by just saying disk 3. And this is, again, the central pixel is right here. So it goes 3 this way, 3 that way, 3 top, and 3 bottom. Okay, so it creates this matrix where these pixels are all multiplied by 0. These pixels are multiplied by 1 when it's actually moving on top of your image. That's what the disk size actually means here. Okay, it's a kernel size. Okay, and our mode equals to constant and C value equals to 0. If you don't give anything, that's by default. I'm just giving it implicitly here, so we make sure that, okay, this is applied. Okay, so again, what is mode? If you watch my previous tutorials, you probably know what it is. It's nothing but, okay, when this kernel gets to the end of the image, how do you deal with the end pixels? Because there is nothing to the right of it. So it's going to add some pixels with a constant value. In this example, constant value of 0. That's all. This is how easy it is to apply your median filter. So let's go ahead and look at the output. And for that, I'm going to use OpenCV. And again, I covered this topic a couple of times in the previous tutorials. To look at images in OpenCV, it's cv2.imshow, whatever you want to visualize, and do not forget to add these 2 lines, otherwise the images get stuck there forever. Okay, so let's go ahead and run it and look at the output. And here you go. And this is our original image with some Gaussian noise. And here is the median image, and you can still see a lot of a lot of stuff happening in the background over there. And how is our, I mean, it's not like it didn't work, it actually did a decent job. So here is the median using scikit-image. Okay, so the math is the same. Then how come the output images don't look exactly the same? Well, the math is the same, but here we are defining a disk size, and here we are defining a kernel size. The kernel sizes are different. That's why the outputs look slightly different. Okay, if you get the same kernel size, then the math is the same. Okay, so now let's actually look at the salt and pepper noise. So instead of Gaussian, let's actually do salt and pepper and do the exact same exercise. So this should be slightly better. I'm not sure how clear again it is coming off over the video, but you can see a lot of dark pixels on this nuclei, a lot of bright, salt, I should say, and this is the pepper, right? So salt's showing up on this dark background. So if you actually, let me close that, and if you look at the scikit image, it looks very clean, nothing in the background. Okay, this one looks even better. OpenCV, because the kernel size is a bit smaller. Nothing, very clean compared to the original image. So as you can see, this is doing an amazing job on salt and pepper type of images. On Gaussian, it's doing an okay job. I mean, it's still doing something, but its primary purpose is for salt and pepper. Okay, so I hope you learned something from this tutorial. In the next one, let's do another denoising. There are at least 3 or 4 others that I would like to cover that actually work in different situations. So let's actually meet again in the next tutorial. Thank you very much.